It is winter in Yellowstone National Park, and the temperature has dropped to 20 below zero. The landscape is a study in silence. Snow sits thick on the lodgepole pines. The Lamar Valley stretches wide and pale under a sky the color of old iron. Nothing moves. Nothing, that is, except for a pair of black shapes riding the thermals high above the tree line. They tilt and bank without a single wing beat. They are watching. They are always watching. And somewhere below them, hidden among the willows along the frozen river, a pack of wolves is on the move. Most people who come to Yellowstone in winter are hoping to see wolves. They set up spotting scopes on the roadside pullouts and wait for hours in the bitter cold. But the visitors who know where to look do not just watch the wolves. They watch the ravens. Because wherever the ravens go in this valley, the wolves are sure to follow. And wherever the wolves go, the ravens follow right back. This relationship has been playing out across the northern wilderness for so long that nobody alive today can say with certainty when it began. What we can say is this: it is one of the most extraordinary partnerships in the entire animal kingdom, and it is not what it appears to be on the surface. If you enjoy stories about the hidden intelligence of wild animals and the surprising ways that nature finds to solve its most difficult problems, stay with this one, because what happens between ravens and wolves reaches into territory that biologists are only now beginning to fully understand. Hit subscribe so you never miss another story like this one, because we are just getting started. The common raven, Corvus corax, is the largest member of the crow family. It has a wingspan that can reach nearly 5 feet. Its beak is heavy and curved, built like a tool rather than an ornament. Its feathers are not simply black. In the right light, they shift through purple and blue and green, like oil on dark water. Ravens are found across the entire northern hemisphere, from the Arctic tundra, down through the boreal forests of Canada and Russia, across Europe, into the mountains of North Africa and Central Asia. They are birds of cold places and high places and high places, and they have lived alongside wolves for as long as wolves have existed on this planet. In the deep winter of Yellowstone, the Lamar Canyon wolf pack sets out before dawn. There are 7 of them this season, moving in single file along a trail packed hard by previous journeys. The alpha female leads. She is 10 years old and knows this valley better than any wolf alive. Behind her come the others, each stepping precisely into the footprints of the wolf ahead, conserving energy in the deep snow. They are heading toward a herd of elk that bedded down near the river the previous evening. And above them, 2 ravens are already airborne. These are not the same 2 ravens that happened to notice the wolves from a thermal and decided to follow out of idle curiosity. These are specific individuals. Ravens have been documented forming long-term associations with specific wolf packs, following the same group across hundreds of square kilometers of territory, learning the pack's behavior, anticipating their routes, and arriving at kill sites sometimes before the wolves themselves have finished the hunt. This is not coincidence. This is a relationship that has been cultivated over time, and the ravens are active and strategic participants in it. When the elk herd comes into view, the ravens descend. They do not land. They circle, low and fast, clattering and calling. The elk raise their heads. Some begin to shift. The wolves, still concealed in the willows, read the ravens' behavior. They know what those calls mean. They know the direction the ravens are circling. They use this information. The hunt begins. There is a debate that has occupied ecologists and animal behaviorists for decades. When a raven leads a predator to prey, is it doing so deliberately? Is there intention behind that behavior? Or is the raven simply reacting to stimuli in its environment in ways that happen to benefit wolves by accident? The more we study corvids, the more the answer seems to lean toward the deliberate. Ravens are not automatons. They plan, they remember, they deceive, they play, and they keep score. To understand why this matters, you have to start at the beginning. Not the beginning of the wolf and the raven in Yellowstone, but further back, much further back. To the time when wolves first began hunting the large ungulates of the northern hemisphere, and ravens first began to notice that where wolves hunted, food could be found. The relationship almost certainly predates modern wolves as we know them. The ancestral gray wolf, Canis lupus, diverged from its canid ancestors somewhere around 300,000 years ago, though the fossil record suggests that corvid-canid associations are even older than that, going back to interactions between ravens and earlier wolf-like predators on the Pleistocene steppe. These were landscapes of extraordinary abundance, populated by mammoths and woolly rhinoceroses and giant bison, and the predators that hunted them, and the scavengers that followed those predators. Ravens were there. They watched. They learned. They survived. What ravens were solving in those ancient landscapes was a problem that remains exactly the same today. A raven cannot open a large carcass on its own. A raven's beak is strong, but the hide of an elk or a bison or a caribou is thick and tough. In the deep cold of winter, a frozen carcass might as well be a rock. Ravens can pick at the eyes and the soft tissues around the mouth and nose. They can work at a wound already opened, but they cannot breach intact hide over the hindquarters or the body cavity. They need someone to open the package for them, and for hundreds of thousands of years, that someone has been the wolf. So the basic logic seems simple enough. Ravens follow wolves, wolves make kills, ravens eat. But this explanation, while accurate as far as it goes, is wildly incomplete. Because the relationship runs in both directions, with a complexity and an intimacy that goes far beyond simple scavenging. To tell the full story, you need to spend time in the field. You need to watch what actually happens when ravens and wolves are together in the same place. Biologists who study ravens in Yellowstone have counted as many as 100 individual ravens at a single wolf kill. That is a lot of birds, and they do not arrive all at once. The first ravens are there within minutes of a kill, sometimes before the wolves have even begun to feed. This raises an immediate question. How do they know? How does a raven 2 miles away, perched in a spruce tree, know that a kill has just been made over the ridge? The answer involves a combination of sensory acuity and what researchers have come to describe as a communication network. Ravens have extraordinarily sharp eyesight, calibrated for movement over long distances, but more than that, they watch each other. When one raven changes its flight pattern, drops altitude, or begins to circle over a particular point, other ravens notice. A signal passes through the aerial network, invisible to human eyes, but unmistakable to the birds themselves. The gathering begins. By the time a wolf pack has opened a large elk carcass, the ravens are already overhead, and within an hour, the word has spread for miles in every direction. This is the beginning of the feeding assembly. And it is here that something remarkable happens, something that researchers have described as deeply surprising, given what we thought we understood about the social lives of ravens. Ravens, when feeding at a wolf kill, do not simply compete with one another for access to the carcass. They also compete with the wolves, and they are good at it. A raven will walk directly up to a feeding wolf and peck at its tail. The wolf turns. Another raven darts in from the opposite side and steals a piece of meat. The wolf turns back. The first raven is already pulling at the carcass from a third angle. This is coordinated piracy. It requires timing, spatial awareness, and an understanding of the individual wolf's behavior and tolerance threshold. Wolves have different personalities. Some are highly tolerant of ravens and barely react to their antics. Others are more aggressive and will chase birds away from the carcass repeatedly. Ravens learn which wolves are which. They test new pack members quickly. They remember the outcomes of previous encounters. A raven that has had a piece of meat stolen by a wolf will not approach that individual again in the same way, but it will approach a more tolerant packmate with greater confidence. This is not stimulus and response. This is social intelligence applied to interspecies interaction. The wolves, for their part, have learned something equally important. Ravens are effective early warning systems. Multiple studies in Yellowstone and in the Carpathian Mountains of Eastern Europe have found that wolves hunting in the presence of ravens are significantly more likely to detect danger early. Wolves do not simply ignore the birds perched in the trees above them. They watch them. When ravens suddenly take flight or begin alarm calling, wolves raise their heads, scan the environment, and often move. The birds are reading the landscape from above, a vantage point no wolf can access, and their behavior broadcasts information that wolves have learned to interpret. There is a striking account from a researcher working in the Białowieża forest in Poland, one of the last remnants of the ancient European forest, where both wolves and ravens still exist in significant numbers. The researcher was tracking a small wolf pack when the wolves stopped abruptly, all at once, heads up, eyes locked on a group of ravens that had risen suddenly from a stand of oaks, 200 meters to the north. The wolves held for several seconds, then turned and moved south, away from the disturbance. 45 minutes later, the researcher found evidence of human hunters in precisely the location the ravens had been alarmed by. The wolves had used the ravens as a scout team. The ravens had saved the wolves from a potentially deadly encounter, and almost certainly, they had done it before. What makes this even more fascinating is the question of what the ravens gain from warning the wolves. On the surface, you might say the raven gains nothing from keeping the wolf alive in that moment. The wolf is not the raven's meal. But look at the longer timeline. A wolf pack that survives makes more kills over the course of a winter. More kills means more feeding opportunities for the ravens that follow that pack. Keeping the wolves alive is an investment in future food. Whether ravens consciously calculate this in the way a human investor might is a question that science cannot yet fully answer. But the behavior is consistent with that logic, repeated across multiple populations in multiple ecosystems over time. Yellowstone is the laboratory, but it is not the only one. The wolves were extirpated from Yellowstone in the 1920s, and with them went much of the complex ecological machinery that depends on apex predators. When wolves were reintroduced in 1995, bringing 14 animals from Alberta into a park that had not seen wolves in 70 years, the ravens were there immediately. The first Yellowstone wolves arrived in winter. They were released from acclimation pens into the Lamar Valley. Within days, ravens were circling their enclosures. By the time the wolves made their first major kill in the wild, ravens were present at the carcass within the hour. This was not ravens from a local tradition that had been maintained in the wolves' absence. There were no Yellowstone wolves to follow for 3/4 of a century. What this suggests is that the raven's association with wolves is not purely learned cultural behavior passed down through specific raven populations. It has a deeper basis. It is, to a degree, instinctive. The behavioral template for following large predators to food sources is built into the raven in a way that does not require previous exposure to wolves. A raven that has never seen a wolf knows, on some fundamental level, that a large carnivore moving purposefully through a landscape is worth following. This is a remarkable claim, and it deserves closer examination, because if it is true, it tells us something extraordinary about the evolutionary history of the raven. It means that the association between ravens and wolves is not a learned trick or a cultural quirk maintained by specific populations. It means the relationship has been going on long enough and been consistent enough in its benefits to become encoded in the raven's biology. The raven that follows a wolf is not thinking about why it is doing so in any analytical way. It is doing so because its ancestors that followed wolves ate better, survived longer, and reproduced more successfully than the ravens that did not. The follower genes propagated. The tendency to follow large predators became a fixed feature of what it means to be a raven. In the cold morning of the Lamar Valley, the alpha female has brought down an elk cow. It was a long chase, more than a mile across the valley floor, and the pack is tired. The elk is a large animal, heavy-bodied and well-fleshed, enough to feed the entire pack for several days if they can defend it. The wolves are feeding, the ravens are feeding, and in this frozen place, with wind driving snow crystals across the white expanse, something ancient and functional and oddly beautiful is unfolding. But the relationship between ravens and wolves in Yellowstone goes beyond feeding. Far beyond it, researchers studying wolf packs in Yellowstone began to notice something that was difficult to explain at first. Wolves that had more ravens associated with their pack showed different movement patterns than wolves with fewer ravens. They covered more ground in a day. They changed direction more frequently, and crucially, they were more successful hunters. The initial hypothesis was straightforward. More ravens means more scouts, means better information about prey locations. But there was another explanation that nobody initially considered. Ravens play with wolves. Not play in any metaphorical sense. Actual play. Ravens have been documented approaching resting wolves and engaging in what can only be described as games. A raven will walk up to a wolf pup and pull its tail, then hop backward as the pup lunges. The raven pulls the tail again. The pup chases. The raven lifts off, circles, lands behind the pup, and pulls the tail from the other side. This goes on for extended periods, and both participants show every behavioral indicator of enjoyment. The wolf's body language is loose and bouncy. Its tail is high, its ears are forward. It is playing. The raven is hopping and tilting its head and vocalizing softly. It too is playing. This is astonishing behavior to observe, because cross-species play between a predator and a bird. that the predator could easily catch and kill in normal circumstances is not supposed to happen. It happens because the raven has read the wolf well enough to know when it is in a predatory state and when it is in a playful state, and it exploits the playful state to engage in something that, from the outside, looks very much like friendship. The implications of this are profound. If ravens and wolves are engaging in genuine social interaction beyond the simple transactional exchange of information for food, then the relationship is not merely mutualism in the ecological sense, it is a social bond, and social bonds create loyalty. A raven that has played with a particular wolf may be more likely to follow that wolf, to watch for it, to signal to it. A wolf that has grown up playing with ravens may be more comfortable around them, more attentive to their signals, more willing to share access to kills. Rick McIntyre, who spent more than 20 years observing wolves in Yellowstone and compiled arguably the most detailed record of wolf behavior ever assembled, has written about wolves that had particular relationships with individual ravens. Wolves that would approach specific birds, that would interact with them differently than with others, that seemed to recognize them as individuals. Ravens, for their part, recognize individual wolves. They have been shown in controlled experiments to distinguish between photographs of familiar and unfamiliar individuals, and their responses to these photographs differ. This is not simple pattern recognition. It is the recognition of social actors in a shared world. We need to pause here and appreciate the cognitive requirements of all this. What the raven-wolf relationship demands of both species is extraordinary. A raven following a wolf pack must track the pack's location over large distances and changing terrain. It must assess the hunting behavior of multiple individual wolves, understand pack hierarchy, and which individuals have priority access to a kill, remember the outcomes of previous encounters with specific animals, communicate information about prey and danger to conspecifics through behavior and vocalization, and modulate its own behavior based on current social context. A raven that approaches a tolerant subordinate wolf at a carcass is making a completely different calculation than a raven approaching the alpha during an active feed. Meanwhile, the wolf must integrate raven behavior into its own decision-making in real time. A hunting wolf that hears a raven alarm call must assess whether the call is relevant to its current situation, what direction the disturbance is coming from, and how to adjust its own behavior accordingly. It must do this while simultaneously managing pack coordination, monitoring prey behavior, and attending to its own physical state. The cognitive load on both species in this relationship is extraordinary. And ravens are more than up to the task. Corvids have long been recognized as among the most cognitively sophisticated animals on Earth. Tool use has been documented in New Caledonian crows. Planning for future states has been demonstrated in Eurasian jays. Ravens have passed false belief tests that were once considered markers of a level of social cognition unique to great apes. They understand that other individuals have knowledge and perspectives different from their own. They can deceive. They can cooperate. They can wait. The waiting is particularly important. Ravens have been shown in experiments to defer immediate reward in order to achieve a larger reward later. This capacity for impulse control and delayed gratification is rare in the animal kingdom. In the context of the wolf-raven relationship, it may manifest as a raven allowing wolves to finish feeding before descending to the carcass, because experience has taught it that the wolves will eventually leave and the raven can feed in peace, rather than constantly harassing active feeders and risking injury. But ravens also push the limits of what wolves will tolerate, and they push those limits intelligently. A raven that has harassed a wolf too aggressively at a carcass will be snapped at, sometimes successfully. Ravens do get caught by wolves. They are killed occasionally. But this is rare, and the raven's behavioral repertoire is rich enough to minimize the risk while maximizing the benefit. The ability to read the specific tolerance level of a specific wolf on a specific day is a skill that takes time to develop, and young ravens are considerably less successful at carcass theft than experienced adults. This is where the play behavior becomes important in a different way. Young ravens that play with wolf pups are learning something that will serve them for years. They are learning how wolves move, how they signal mood changes, how much warning they give before a snap, how quickly they can turn, and at what angle. The play is not just recreation, it is education. And the wolf pups are learning the same things about ravens from the other side of the interaction. In the Finnish forests north of the Arctic Circle, a researcher named Jukka Saarinen spent 3 winters following a pack of 8 wolves across their territory, a vast expanse of spruce and birch and frozen lake. He was particularly interested in the ravens that accompanied the pack. What he found was that the pack had what he described as a core group of ravens, somewhere between 6 and 12 individual birds that were consistently present with the wolves, and a larger, more fluid population of occasional followers that appeared mainly at kills. The core group behaved differently. They traveled with the wolves, they perched near resting sites, they appeared to monitor the wolves' behavior continuously, and their responses to environmental stimuli were tightly linked to the wolves' own reactions. Saarinen recorded an incident in which the core raven group began alarm calling from the trees near the wolf pack's resting site before the wolves themselves showed any sign of disturbance. Several minutes later, a wolverine appeared from the east, moving toward the resting site. The wolves responded immediately when they scented it, driving it off. But Saarinen was left with the strong impression that the ravens had detected the wolverine first, and that their alarm behavior had primed the wolves for the threat. Whether this was a deliberate warning or simply a byproduct of the raven's own alarm response that the wolves happened to interpret correctly is impossible to say with certainty. But the outcome was clear. The wolves benefited from the raven's superior aerial vantage point. The wolverine encounter points to something that is easy to overlook in the romantic narrative of ravens and wolves. This relationship exists in a competitive and dangerous world. The carcasses that form the foundation of the partnership are contested by many species. In Yellowstone, a wolf kill will attract not just ravens but also coyotes, eagles, foxes, magpies, and in some seasons, grizzly bears. A grizzly can displace an entire wolf pack from a kill. The wolves cannot prevent it, but they can sometimes resist it if they have advance warning. Ravens have been observed behaving in ways that appeared to alert wolves to approaching grizzlies. The birds begin alarm calling and moving in ways that diverge from their normal feeding behavior. The wolves, attuned to the raven's signals, raise their heads, locate the threat, and either prepare to contest the bear or abandon the carcass depending on pack size and individual bear behavior. In either case, the raven's signal gave the wolves crucial seconds of preparation time that could make the difference between an orderly retreat and a chaotic one in which wolves might be injured. But perhaps the most extraordinary aspect of this relationship is how it changes the wolf as a hunter. A wolf hunting alone has a certain probability of success. A wolf pack hunting together has a higher probability of success. But a wolf pack that has ravens above them operates with an informational advantage that approaches something almost technological in its effectiveness. Ravens routinely fly ahead of the direction the wolves are traveling. This is documented behavior, not anecdote. The birds move out in the direction of travel, scan the terrain, and return. Or they circle over a distant location where prey has been detected, drawing the wolves' attention. In effect, the ravens function as aerial scouts for a ground-based hunting party. They extend the wolves' sensory reach by miles. They allow the wolves to detect prey concentrations over ridgelines and through forest that would otherwise require hours of ground searching. The wolves, in turn, provide the ravens with something that no amount of aerial scouting can substitute for: the ability to access food that the ravens cannot process on their own. This is the core of the mutualism. It is not a relationship of equals in the sense that both parties contribute the same things. It is a relationship of complementary capabilities. The ravens bring sight and aerial mobility and early warning capacity. The wolves bring physical power and the ability to bring down and open large prey. Together, they form a composite hunting and foraging system that is more effective than either species alone. The combined entity, if we can call it that, has been described by at least one researcher as a functional superorganism. That is an extreme claim and a controversial one, and it is worth being careful about what it means. A superorganism, in the strict biological sense, is a group of organisms that functions as a single entity, like a colony of ants or bees. Ravens and wolves are not a superorganism in that sense. They are two separate species with separate evolutionary interests and separate decision-making systems that happen to have found a stable and mutually beneficial way of operating together. But the functional output of their cooperation does approach something superorganism-like in its efficiency. The combined detection, pursuit, and processing capacity of a wolf pack with an associated raven group significantly exceeds what either species could achieve independently. There is a winter in Yellowstone that has become something of a reference point in the literature on this relationship. The winter of 2011 to 2012 was hard even by Yellowstone standards. Temperatures dropped below -30 on multiple occasions. The snowpack was deep and crusted and difficult for elk to move through. The wolf packs were struggling. The Lamar Canyon pack, then one of the most closely studied in the park, had taken heavy losses the previous spring and was operating with reduced numbers. Food was scarce. Several of the packs in the park were stressed, but the Lamar Canyon pack, more than others, maintained a consistent association with a large group of ravens that winter, somewhere between 15 and 25 birds at various times. And what the researchers noted was that the pack's hunting success was actually higher that winter than in the previous 2 winters, despite their reduced numbers. They made kills at a higher rate relative to pack size than the statistical models would have predicted. And the pattern of those kills suggested a high degree of information efficiency in locating prey. They were not covering as much ground randomly searching. They were traveling with purpose. The ravens were credited, tentatively, with a significant portion of this efficiency. The birds were ranging widely in front of the pack's line of travel, and on several documented occasions, the pack changed direction based on apparent raven behavior before any ground-level prey detection could have occurred. The correlation was not perfect. There are many confounding variables in wild ecology, and attributing a causal role to raven behavior in specific hunts requires a level of controlled observation that field research cannot always achieve. But the pattern was there, consistent across multiple observations by multiple researchers, and it was not explained by any other factor identified at the time. There is another dimension to this relationship that has received less attention than the hunting and scavenging dynamics, but may be equally important in the long run. Ravens are extraordinarily sensitive to changes in wolf pack composition and dynamics. When a new wolf joins a pack or when a dominant individual dies, the raven group associated with that pack shows measurable behavioral changes. They become more cautious. They test the new hierarchy. They adjust their carcass feeding strategies based on the revised dominant structure of the pack. This sensitivity means that ravens track wolf pack dynamics with a level of attention that goes beyond simple feeding opportunism. They are maintaining a model of the social structure of the pack, updating it as the pack changes, and adjusting their own behavior accordingly. This is sophisticated social cognition applied across a species boundary. It requires the raven to hold and update a mental representation of a social group that it does not belong to, in a species that is fundamentally different from itself. Researchers studying mirror self-recognition in ravens, a test traditionally used to assess higher-order self-awareness, have found that ravens demonstrate behaviors consistent with self-recognition in some contexts. This is a remarkably short list of species that show this capacity: great apes, bottlenose dolphins, Asian elephants, humans, and corvids. The company ravens keep in this category tells you something about the cognitive league they are playing in. In the Carpathian Mountains of Romania, where wolves have maintained continuous populations through the centuries of persecution that eliminated them from most of Western Europe, the relationship between ravens and wolves takes a form that is somewhat different from Yellowstone. Here, the landscape is more forested, more broken, and the prey base is different, including red deer, roe deer, and wild boar. The wolf packs are smaller on average than in Yellowstone, and the raven groups that follow them are correspondingly smaller. But the fundamental dynamics are the same. What is different in the Carpathians is the historical depth of human observation of this relationship. The people who have lived in these mountains for generations, shepherds and hunters and foresters, have their own understanding of the wolf-raven connection, built from direct experience over centuries. In the traditional knowledge of Romanian mountain communities, there is a saying that can be roughly translated as, "Where the ravens circle, the wolf has been." This is practical wisdom applied to livestock management. A shepherd who sees ravens behaving in a particular way in a particular part of the mountain knows that wolves have recently made a kill in that area and will move his flock accordingly. This traditional knowledge contains something scientifically interesting. It reflects an observation that is not just about ravens following wolves, but about ravens marking territory where wolves have been active. Ravens in wolf territories do not just follow live wolf packs. They also patrol the edges of wolf pack territories, responding to scent markings and kill sites left by wolves. A raven with experience in wolf territory behavior can read the landscape in ways that encode information about wolf activity even in the absence of the wolves themselves. And human observers living in close enough relationship with the land have noticed this and built it into their knowledge systems. This is part of a broader pattern in which the wolf-raven relationship exists embedded in larger ecosystems and cultures, shaping not just the ecology of the places where it occurs, but also the knowledge and practice of the people who live in those places. Indigenous cultures across the Northern Hemisphere have recognized the wolf-raven relationship and incorporated it into their understanding of the world. The peoples of the Pacific Northwest, the Norse, the peoples of the Siberian taiga, and many others have stories and traditions that reflect an awareness of this bond. In Norse mythology, Odin's ravens, Hugin and Munin, whose names translate as thought and memory, were said to fly across the world each day and return to Odin with knowledge of all that had happened. Odin was also the god of wolves. His wolves, Jerry and Freki, sat at his feet. The association of the all-seeing god with both ravens and wolves is not arbitrary. People living in northern forests would have known the wolf-raven relationship intimately. It would have been part of their daily reality. And when they built their mythology, they built into it the same logic they observed in nature. The aerial scouts that carry information. The ground-based predators that use that information. Together they know everything. Together they miss nothing. The Abenaki people of northeastern North America describe the raven as a guide and the wolf as its earthly partner, a formulation that captures the functional reality of the relationship with striking accuracy. The raven guides, the wolf follows, the wolf kills, the raven feeds, the cycle continues. There is nothing mystical about this, though the people who observed it found it worthy of including in their understanding of the sacred. What it represents is a recognition, arrived at through long observation, that these two species have worked out something together that neither could accomplish alone. Back in the Lamar Valley, the feeding is over. The wolves have fed well and are resting in a loose group near a stand of cottonwoods at the river's edge. Several of them sleep. Two younger wolves play in the snow, tumbling and mock-biting with an ease that belongs entirely to the well-fed. Above them, in the cottonwood branches, 3 ravens sit. They are not feeding. They are watching. One of them drops from the branch, glides low over the sleeping wolves, and lands 2 feet from a young male wolf who is resting with his head on his paws. The wolf opens one eye. The raven walks closer. The wolf raises his head. The raven pecks once at the wolf's paw, very gently, almost experimentally. The wolf's tail thumps twice in the snow. The raven hops sideways. The wolf stands. The game begins. To watch this is to feel something shift in your understanding of where intelligence lives in the world. We tend to think of intelligence as a property of brains, of individual minds working on individual problems. But what the raven and the wolf are doing here suggests that intelligence can also be a property of a relationship. The two-species system, the aerial and the terrestrial, the mapper and the mover, the scout and the striker, together constitutes something smarter and more capable than either part alone. Evolution has built a distributed cognitive system out of 2 very different animals. The question of whether this is intelligence is almost semantic. The question of whether it works is not. It manifestly does. The benefits of the relationship extend beyond the direct participants. The wolf-raven complex is what ecologists call a keystone interaction, meaning that its effects ripple outward through the ecosystem in ways that are disproportionate to the direct number of animals involved. Wolves kill elk and deer. The carcasses they leave behind, partially consumed and then abandoned or scavenged, provide food for an enormous range of other species. In Yellowstone, the list of species that feed on wolf kills includes ravens, bald eagles, golden eagles, red-tailed hawks, rough-legged hawks, coyotes, foxes, wolverines, pine martens, weasels, and a long roster of invertebrates that process the remaining organic material into the soil. A wolf kill in winter is an ecological event. It is a redistribution of energy, a pulse of nutrients into a system that is otherwise locked under ice and snow. Ravens amplify this effect. By descending on kills in large numbers and feeding rapidly, ravens transport nutrients away from the kill site in their gut. They fly miles from the carcass, defecating seeds and organic material across the landscape. They feed their nestlings with meat from wolf kills, injecting protein from one part of the ecosystem into another. They cache food from kills in dozens of locations across their territory, burying pieces of meat that may feed other species if the raven fails to retrieve them. The raven is not just a participant in the wolf's hunting system. It is a mechanism for distributing the results of that system across the wider landscape. And then there is the trophic cascade effect. This is one of the most important ecological concepts to emerge from the Yellowstone wolf reintroduction, and it is directly relevant to the wolf-raven relationship. When wolves returned to Yellowstone, the behavior of the elk herds changed. Elk had previously grazed intensively in river valleys without the fear of predation. When wolves came back, elk began avoiding areas where they were vulnerable to ambush, particularly dense streamside vegetation. The willows and aspens and cottonwoods that the elk had been suppressing through overgrazing began to recover. The recovering vegetation stabilized riverbanks. Beaver returned. The rivers themselves began to change course, more slowly and gently, in patterns that ecologists describe as geomorphic recovery. This cascade of effects, from wolves through elk, through vegetation, through rivers, has been documented and debated extensively in the ecological literature. It is sometimes called the ecology of fear, the idea that the presence of predators changes the behavior of prey in ways that have landscape-level consequences. The wolf is the primary agent of this cascade, but the raven is an amplifier. The ravens that follow wolf packs make those packs more efficient hunters. More efficient hunting means more consistent predation pressure on elk. More consistent predation pressure means elk behavior modification is maintained across a larger spatial area. The raven, by making the wolf a better predator, contributes to the trophic cascade. It is a small contribution, perhaps, measured against the wolf's primary role, but it is real and it is measurable. The winter is deepening in Yellowstone, daylight is short, and the cold is absolute, and the Lamar Valley is buried under a meter of snow. In the spruce trees along the northern edge of the valley, a group of ravens is roosting. They gathered here before sunset, coming from different parts of the valley, arriving singly and in pairs, filling the upper branches of the dark trees until there are perhaps 30 birds in the roost. They will spend the night here, pressed together for warmth, talking in the low, gurgling, intimate vocabulary of ravens at rest. In the morning, before the light is fully established, they will scatter across the valley. Some will range widely, flying the ridgelines and the drainages in search of whatever the night has produced. And some, the core followers, the experienced individuals who have learned that the wolves are their most reliable food source, will fly directly toward the last known location of the Lamar Canyon pack. They will find the wolves, they will orient to the direction the pack is moving. They will fan out ahead, read the terrain, and return with information that no wolf could have gathered on its own. And the wolves, heads up, alert to the movement of the birds above them, will adjust their course. The aerial scouts have checked in. The territory is ahead, and the day's hunting is about to begin. What began in the deep evolutionary past as an opportunistic association, a bird following a predator tolerating a bird, has become something far more elaborate than simple opportunism. It has become a partnership. Not a partnership in the human sense, not a conscious agreement or a formalized arrangement. A partnership in the deeper biological sense. A stable, mutually reinforcing relationship that has shaped both participants over time, that has influenced their behavior and their cognition and their ecology, that continues to function across the full range of wild northern landscapes. And that represents one of the most remarkable examples of interspecies cooperation that the living world has produced. The raven did not follow the wolf because it liked wolves. It followed the wolf because wolves could open things that ravens could not. The wolf did not tolerate the raven because it valued ravens. It tolerated the raven because ravens could see things that wolves could not. But over thousands of generations, over the vast expanse of time in which these two species have shared the northern wilderness, something more than utility has developed. The play is real. The individual recognition is real. The specific associations between specific birds and specific packs are real. The ravens know the wolves. The wolves know the ravens. And in knowing each other, these two animals have become something that neither could be alone. The raven makes the wolf see further. The wolf makes the raven fed. And between them, in the cold air above the frozen valley, in the specific tilts and turns of a pair of black wings that a hunting wolf has learned to read as clearly as any track in the snow, there is a language that has no human name, but it has been spoken, in one form or another, across the whole long history of the wild north. And it is being spoken still, this morning, in the Lamar Valley, as the light comes up and the ravens lift from the spruce trees and go to find the wolves. The elk herd has moved overnight. They are 2 miles east of where they bedded. The ravens found them at first light. The wolf pack does not know this yet. But they will, because 3 ravens from the core group are already in the air. already moving, already describing with their flight the invisible line that connects a pack of wolves to a herd of elk, to a meal, to another day of survival in the hardest season of the hardest year. The partnership holds. It has always held. In the Lamar Valley and the Carpathians and the Finnish forests and the Siberian taiga, wherever wolves have walked and ravens have flown, the deal is the same. You hunt, I scout, you open, I feed, I watch, you listen. Together we eat, together we endure. Two species, one functional system, ancient as the ice and as current as this morning's tracks in the snow. Watch the ravens and you will find the wolves. Watch the wolves and you will understand why the ravens are there. Watch both together and you will see something that is not quite predator and not quite scavenger and not quite partnership in any word we have for it. You will see an alliance that time has made essential. You will see what it looks like when evolution builds intelligence, not in a single mind, but in the space between two species that need each other. That space, cold and wide and crossed by black wings above the silent valley, is where the story lives.